Hello, everybody. My name is Moryan Tchoumi. Today I'll be talking about UV migration. It's a project that I did during my internship at Red Hat. So a little bit about myself. I'm a senior at Boston University studying computer science. Like I said, I worked at Red Hat on the OpenShift AI IDE team. So I did a lot of the back end for them. I helped them a lot with automation and back end optimization. So the challenge that I was instructed to try to solve was the um, the IDE team has a lot of images, and each image have their own dependencies that are installed for the notebook images. And so at the time when I got there, they're using Pipenv to install all of their dependencies. And they're wondering if there was a better way for them to do it, since Pip was really slow and updating all their dependencies took a long time, and locking them up took a long time since they had so many different notebook images that had different dependencies within themselves. So my job was try to see if I can use UV to update it to be more optimized. So as I said, the project goal was to utilize UV's advanced features to enhance the performance and reliability of their notebook images, and streamline the notebook images just to be better for developers to use and update the dependencies. So why UV? So UV is marketed as a really fast package manager for Python, and it's supposed to take all the other Python managers that you use beforehand, like pip and poetry, and combine them together into one package. And using UV, you're able to do everything you did in all the other Python managers, but but using one singular manager and one singular file. So the first goal was to streamline the configuration. The first thing I did was update the Docker files to use UV. So I just ran a pip install to install UV within every image. After that, I installed using UV all the requirements from a requirement.txt file. And then the second thing was to consolidate all the dependencies into one singular pyProject.toml file. And this comes with three major issues. I have to find a way to manage multiple different package versions, multiple different dependency versions, and multiple different Python versions. As during the time at my internship, they were moving from 3.11 to 3.12 for the notebook images. So when you're trying to manage multiple different package versions with UV, UV introduces this thing called groups. As you can see, you can create a group and have multiple different packages within that group. And within each group, I can state that this group and this group conflict with each other, making it so that dependencies only install when that group is called and no other dependencies is installed. So I can have TensorFlow install NumPy 1.26 while also installing NumPy 2.2 for all of my other notebook images. A second thing that UV allows you to do is use sources. Different for PyTorch, different GPUs installs PyTorch from different sources. So you have to use groups and sources to install those packages from that in particular source. And UV allows you to use groups and the sources and indicate which source that purchase is getting installed from. So I can have a PyTorch CUDA and a PyTorch Rockham for different notebook images. Now, dependencies is a little bit more difficult because after you install your packages with a particular version, the packages themselves install dependencies, and usually you don't always know which dependencies. If you do know the exact dependencies, you can always hard write that as a package. But some dependencies pop out of nowhere. So UV has a dependency metadata that allows you to take the name of that dependency and lock the certain version. This makes it so the dependency conflict that usually comes up with pip can be mitigated using UV. A second thing that it allows you to use is environmental markers. So depending on the computer, some dependencies pop up. So TensorFlow CPU AWS, if you're on a Mac, will always pop up when you try to install TensorFlow. But if you have an environmental marker to lock it to not install on Linux, you can have that in the dependency metadata and force TensorFlow Rockham to not install that dependency when it's installed on Linux. Now, managing multiple Python versions comes with environmental markers as well. You have multiple different Python versions. You can just link which packages install with which Python version, and all the different Python versions can be installed using the command and a parameter for Python versions. Then additionally, you can use the groups. So I can have multiple different Python versions, multiple different groups installed using this one command, and have all the files and all the dependencies within one file. And then at the end of the day, performance is all that matters. So when I used UV within the images and ran them for the different various images, you can see for the high level GPU packages like PyTorch and TensorFlow, those are significant improvement. And additionally, locking the files was significantly faster. On top, you can see Pipenv took 17 minutes to lock all the files, while UV only took 3 minutes. This just helps the developers since it's so much faster. They can lock the files, update the files, and have everything seamlessly done. I also helped on the also helped creating the automation for these. So I created the automation that ran the ran to lock all the files and ran to update all the files for the team as part of my internship. Any other questions?
So can you restate the benefit of using UV over pip? I saw the like the performance.
Yeah.
There's that benefit, but is there other was there other benefits
Yes,
as
there
well?
are other benefits. Usually, when you use pip, you have those pip files. You when creating those pip files is really hard. You have to use like the development tools to have the packages installed differently. You can't really have a bunch of different packages installed differently without using UV's groups. So that's why UV is better in that experience. Because the team had tried using just the extras and dev development for certain packages that were giving them trouble, but we found that UV was just significantly better at managing those packages than using just normal pip.
Okay. And is this used in production now, or is
Yes, the team when I left was working on putting this into production. Currently, I don't have a full update if it's fully implemented, but from when I last checked, they're working on implementing it into production as we
gotcha?
speak.
Okay, awesome. Yeah,
Yeah.
great work.
Any other questions?
Yeah, so you mentioned that UV allows multiple different versions of a package to be used in the same source file. What does that
Yeah.
look like? So you like import multiple times? Or?
Yeah, so if you ever look into a UV log file, the way the UV log file works is that it will have a package group, and then it will have the installation of the NumPy and its SHA equivalent to that NumPy version, and it will have that multiple different times for other versions that you're going to be installing. So it will have the 1.26 and the 2.2 both inside the log file. So it will install it from that SHA depending on which version you want it to be installed.
Thank you.
You're welcome.
Hi, so you mentioned that UV basically encompasses all the functionality of poetry,
Yeah.
along with other things. So
Yeah.
I'm wondering if I have a project that's already got like the poetry configuration, it's already a poetry project.
Yeah.
Can UV just install that without any modifications?
Yes, UV actually has a lot of features that allow you to migrate from whatever you're using to UV. I remember if you go to the UV website, they have a migration tab that literally allows you to migrate from pip, poetry, and other things that you're using to UV. Because, like they said, UV isn't actually like recreate all those tools. It's more like a wrapper around those tools, so it's usually really easy for you to implement.
Thank you.
You're welcome.
More questions?
Okay. Thank you guys again.